All right, today's lesson is on solving quadratics, but this time we're going to use it by means of a formula, the quadratic formula. It's basically a way of not solving by factoring or not taking the square roots and having to remember plus or minus. It's actually just using the numbers that are in the equation and basically working with just the numbers. So, solving by quadratic formula. As we get started, I want you to get your calculator out. I want you to have that because this is definitely a calculator-driven kind of solving. Okay, the quadratic formula provides an additional way of finding solutions to quadratic equations by taking a look at a formula. Now, obviously this is something that if you were taking the end of the year exam, you would have to remember. So I want you to always have a way to remember it, so I've always sang it. So we're going to sing it like this. Opposite of B, plus or minus square root, plus or minus square root, B squared minus 4AC, B squared minus 4AC, all over 2A, all over 2A. And I will usually sing that a few times. Opposite of B, plus or minus square root, plus or minus square root, B squared minus 4AC, B squared minus 4AC, all over 2A, all over 2A. Now, you'll notice that we're just talking about letter B, letter A, and letter C. Where do we get letter A, letter B, and letter C from? Okay, when the equation says equals 0. So if we have something on the other side, we might have to move it over to the left-hand side or move it all over to the same side. Then pretty much what we're doing is we're going to pull the number off of x squared. That's our A. The number in front of the B, the x term, the B, that's the number in the middle. And then C would actually be the number at the end where there isn't an x. So it's basically pulling those numbers away and working with them. The advantage of a quadratic formula is that it can be used for any quadratic, any of them, whether the answer is a perfectly nice, neat number, or if it's a fraction, or if it's a decimal. This can solve any quadratic. So even for those that won't factor, sometimes there are answers that are decimals, and we've not had to do any that are decimals yet, but we're going to see some today that will be working with decimals. All right, first things first. Let's just go ahead and look at example 1. All right, I'm going to point something out. The quadratic formula, again, I say opposite of B. So when I'm working with the quadratic formula, I do have a negative sign in front of B. And what I want to do is I want to make sure that you know that that negative sign, let me try to get this out of the way. Okay, that recording window needs to stay open. I just don't need to have it out. That negative sign in front of B is considered like opposite, just like we've done before. Opposite of B. So that's, if I say opposite, it is a negative sign, but negative of a negative would be positive. Then it's plus or minus. That's where we're going to get two possible answers. What that means is we're going to add, so if I hide the negative, okay, that means opposite of B plus B squared minus 4AC all over 2A. And then to get my second answer, it's basically like I hide the plus sign, and then it's opposite of B minus the square root of B squared minus 4AC all over 2A. So that's how we're going to end up using that. So that plus or minus is meant to be there, and it's actually the shortest way of writing the quadratic formula really easy. Otherwise, where I have the plus minus, I have a plus version and I have a subtract version, plus or minus. So it's basically like a concise, quick and easy way to write the quadratic formula where you're going to add the two things on top and then you're going to subtract the two things on top. Let's jump into number 1. Number 1, A would be the number in front of x squared. There's not one, it's a 1. B is the number in front of x, it's a positive 2. C is the number at the end, and it's not just 35, but I have to take the sign that's in front, so it's taking negative 35. Okay, so I'm going to solve the quadratic formula this way. Opposite of B, that's going to give me negative 2, because that starts as a positive 2, so this is going to go as negative 2. I'm going to do the plus one first. Then it says b squared. B squared. It's easier, because we're going to have to use our calculator anyway, but this will keep it as neat and concise as possible. I'm going to square the b number as I put it in here. So in your mind, what's b squared, or 2 squared? That's 2 times 2, so I'm going to put that in as a 4. I hope everybody sees that that goes in as a 4. Minus. Now this 4 right here is built into the equation. So minus 4. Then I'm going to times it by a. A is a 1. And times it by c. C is this long big number, negative 35. All right. And again, all of that is under a square root. Okay. All of that under a square root. Then it says all over 2a, all over 2 times the a number, and 2 times the a number would be 2 times 1. All right? So that's how it looks. I'm just plugging numbers into the formula. Okay. First thing I want to do is I want to simplify as much as I can. I want to take this part that's underneath the square root out, and I want to put that part in my calculator first. Let me say that again. We're going to take this part out and put it in our calculator. I did not say use the square root button, so I'm going to pull it out. So grab your calculators. I'll wait and let you get yours. Get it out. All right, now that you've got yours out, and let's turn it on, I want to take the highlighted part and put it in our calculator. Starting with 4 minus 4 times 1 times negative 35. Okay, I could type it in with the parentheses. That little recording box is just in my way. I'm going to slide it over there. All right, so I could type that in. I get 144. If I had used parentheses, I'd get the same thing. 4 minus 4 times 1 times negative 35. Okay, so if I use parentheses or if I use the times key, I get the same thing. So 144. So here's what I want to do next. I want to simplify this part now. It's negative 2, or opposite of b, plus or minus the square root of 144, divided by, or all over 2 times 1, which is just 2. All right? So what I did is I took all of that big long part and I simplified it. Now this particular one, I don't know if you recognize it or not, but I think 144 is a perfect square. What is a perfect square of 144, or square root of 144? Well, it's 12. So out would come a 12. So the top part of this would actually simplify into opposite of 2 plus 12 all over 2. All right. So let's go ahead and add everything on top. Negative 2 plus 12 would be positive 10. 10 divided by 2 actually works all the way out to a 5. My first answer for this problem is x equals 5. Now, I've written pretty big, and I still need to do the other half. Okay, so remember, we have 2 parts to do. The easy thing is once you've done the first part, the second part is a lot easier. This one had a nice, neat, perfect square root. So when I substitute into the second half, it's going to be the same thing. Opposite of b, still negative 2. This time, excuse me, instead of being plus, we're going to do the what? We're going to do the minus, the square root of. Now, this part underneath would be exactly the same. So it's going to be minus 144 all over 2a, which is 2 times 1. So when I do this one, again, this is going to be 12. So it's going to be negative 2 subtract 12 all over 2. Negative 2 subtract 12 is negative 14 divided by 2, and this answer turns out to be negative 7. So my 2 answers are x equals positive 5 and x equals negative 7. I got that from the quadratic formula. Now I know what you're thinking. Why did I have to do all of that? I could have factored this. If I take a minute to go back up and look, this one would have factored. You probably could have went straight to parentheses. You probably could have said what multiplies to give 35, that's going to subtract to give 2, and you probably could have figured out that it was going to be 7 and 5, positive 7, negative 5, split, x plus 7 equals 0. It works out to be x equals negative 7. X minus 5 equals 0, and it works out to be x equals 5. I selected a problem that we began with as being one that we could have solved anyway. Remember what I said? Quadratic formula works for any quadratic. So since it works for any quadratic, this one would have factored, but it also shows you that quadratic formula works anyway. All right? So that's a lot with number 1. I took a long time. I did every step. Hopefully you see how we use the calculator. Really, the part that I really need the calculator for is this part right here that's highlighted inside the square root. Okay, hope you see that part right there. That's the part that we're highlighting. That's the part I really use my calculator on first. All right, let's look at example 2. Example 2. This one I don't think will factor. If you'll take a look here, you're asking yourself what is going to multiply to give 7 that's going to actually have to add to be 6. There isn't anything. 7 times 1, if you added, would be 8. This one will not factor. That means there's probably are numbers that would multiply to give 7 that would add to be 6, but they're decimals. So they would never be anything we could actually think about as factoring. Factoring would not work out. So I'm going to find my values. A would have to be the number in front of x squared, so it's a 1. B is negative 6, and C is positive 7. All right? Here's our formula. X equals. Remember, we're solving for x. Okay? Opposite of B, opposite of B. So this time, opposite of B is positive 6, because it started as negative. Plus or minus, and I'm using both in the same time. Square root of, and it should be a long square root. This time it's going to be b squared. All right, b squared is negative 6. What's negative 6 times negative 6? Positive 36. I hope you figured out if you square any number, even if it's a negative, it becomes positive. Minus 4 times an a number of 1 times a c number of 7. All over 2a, just 2 times 1. This time we're going to use our calculator to find the best answer. All right, grab your calculator. All right, I'm going to type in the part that's under the square root first, just like I did the last time. I'm not doing the square root part. I'm just pulling what's out of there, or right under there in my calculator. So I'm typing in 36 first, minus 4 times 1 times 7. I'm pausing. You also put this in your calculator. Every person, put it in your calculator. Enter. Square root of 8. Okay? Or 8. 8 is the number that's going to end up on the square root. So now I can simplify. Okay? X equals positive 6. Plus and minus is still there. Square root of 8. All over 2 times 1, which is 2. Now, there is something we can do. Do you recognize the square root of 8 as being a number that would break down into, remember, that would be like 4 times 2? And a few days ago, we learned how to simplify. So if you simplify the square root of 4, it comes out as a what? A 2. The 4 is gone. So the square root of 8 is 2, square root of 2. That's all I want you to do with this one, because notice that I have asked you to give me the answer in radical form. Okay? That means that all I want you to do is simplify what's underneath the square root, and then simplify the square root and leave it like that. So I'm going to have 6 plus or minus. The square root of 8 is the same thing as 2, square root of 2, and then I'm going to put it over 2. That is fine, and that is all you need to do for the radical form. The radical form means I am leaving this symbol, this square root symbol, in my answer. It's very likely that you will find an answer similar to that on an ACT, a final course exam, ACT, my tests. Okay, there is a little bit of dividing we could do. We probably could do that. Do you know that the 2 on the bottom is actually a common denominator under the 6, and it's a common denominator under the second term? So if I split that, 6 would have a denominator of 2, plus and minus. 2 square root 2 would also have a denominator of 2. This actually will simplify just a little bit further. 6 divided by 2 is 3, and then 2 cancels out 2. This would actually give me 3 plus and minus square root of 2. I'm going to leave my answer like that. I'm actually going to change my radical form to reflect that I did recognize that I could actually simplify that square root part a little farther. And let me go back and say something about this. This 2 on the outside can be divided by this 2 on the outside because those numbers are just regular 2's. Okay, the square root of 2 is stuck under a square root, so I can't do anything to this square root of 2. But I could do something with this 2 that was out front. And that's what I was able to do, is to simplify that part. Now, how do I get the decimal form? All right, here's the easy part. Calculators. We're going to type this in and change it to a decimal. And there's going to be 2 decimals. Okay, 3 plus. Okay, what I want you to do first of all is I want you to imagine hiding the negative. Not looking at the negative, let's just do the plus. Okay, so let's do the plus part. 3 plus the square root, so second key x squared. You have a bar. I have an older calculator, so I'm doing square root of 2, and I have to keep mine in parentheses. Enter. 4.41. So the first answer is 4.41. Okay, we'll keep that in mind. So when I did the first answer, I get 4.41. Now, calculators, let's not retype that again. I want you to be aware of something called entry. Entry's down here next to the enter key, down in the bottom corner, okay, down here. So I'm going to actually use the entry key. Second key, enter key, which is entry. What did it do? It brought back the last thing I entered on the calculator. I'm going to backspace. I'm going to change the plus sign to a what? Subtraction sign. Because now I'm basically going to ignore the plus sign, and now I'm going to subtract the 2 terms on top, and I'm going to give me my second answer. 1.5, technically 5.8 would actually round up to 5.9. 1.59. So apparently the 2 numbers that would multiply to give 7, that subtracts to be, or actually adds to be 6, is 4.41 and 1.59. And nobody would ever come up with those. Those are too hard of decimals to come up with. This is the advantage to having a quadratic formula. You have the ability to have decimals that would be too hard to ever try to factor. All right, example 3. This one says, be careful, look closely first. What is my A value? This time A is not 8. Although people would just jump on that. A is supposed to be the coefficient in front of x squared, so technically A is 1 because my top is actually out of order. That probably should have been written as x squared plus 8x in the middle plus 5. All right, so that's why 1 is actually the A. B would be 8, C would be 5. This is one that will not factor. I am definitely going to get a decimal. All right, there is nothing I know of that's going to multiply to give 5. It's going to add to give 8. So x equals opposite of B, opposite of B. So negative 8 plus or minus square root, plus or minus square root, draw a big long square root. B squared. So what is 8 squared? Well, that's 8 times 8, which is 64. It's just so much easier to square that number before you put it in there, and that way you don't have as much stuff to try to type in the calculator. Okay, minus 4 times the A number, 1, times the C number of 5. All over 2A, 2 times 1. All right, here we go. What do we do first? Just like the last 2 times, I want to pull out the part that's under the square root, and that's the part I want to type in my calculator. So here I go. Clear out the old stuff. 64 minus 4 times 1 times 5. All right, 44. So now I can simplify this. X equals negative 8 plus my square root of 44 over 2. Now, what we need to do is we need to focus on the square root of 44. That will reduce. All right, so square root of 44, I think, is 4 times 11. Which one is the perfect square? The 4. 4 comes out as a 2. 11 is left under. So now I can replace square root of 44 with 2 square root 11. So I'm going to do that next. Here we go. Negative 8 plus and minus 2 square root 11 over 2. Now, before I write my radical form, I'm going to go ahead and simplify this. 2 is a common denominator under the 8. 2 is also a common denominator under the second term. So when I split that up, it actually is the same as negative 8 with a denominator of 2 plus and minus 2 square root 11 with also a denominator of 2. Now, it's like the last time. This 2 out front and this 2 on the bottom, they're regular 2's because 2's outside the square root, so I can cancel those 2. And then negative 8 divides by negative 2, and my answer is negative 4 plus or minus square root 11. Okay, so that's my radical form. Radical is the name, the generic name for that symbol. This is the radical symbol. Remember? So the answer for the radical form is negative 4 plus and minus square root 11. I want to see that square root in that answer. You need to practice being able to recognize that answer. Now, if I were going to find this answer on a number line, I need the decimal version. So I'm going to have to type that in and change it to a decimal form. Here I go. Negative 4 plus second square root of 11, closing my parentheses, yours has a bar. My first answer is negative 0.68. Negative 0.68. Negative 0.68. That's only the first answer for x. To get the second answer, remember, we're not going to retype. Let's use second entry. Okay, we're going to back, and we're going to change the plus sign to a subtraction sign. Enter. Negative 7.31, but that follows as a 6, negative 7.32. Negative 7.32. All right, so those are two numbers that would multiply to give, I guess, multiply to give 8. That would add to be 5. What did I, was that a negative? Yeah, it was both negatives. All right, here we go. Everybody okay with those solutions? I hope so. Again, I know this is different, but we're having to learn and go farther. All right, example 4. That's the first thing that you see, hopefully. Something different about equals 9. That's a problem. It should say equals 0. So the first thing I really need to do is I need to bring negative 9 over here, and it should become what? Positive 9. So this is really 4x squared plus 12 with x plus 9. All right, so my C is a 9, my B is a 12, and my A this time is a 4. All right, let's plug and chug. That's exactly what we're doing. X equals opposite of B, opposite of B. So it's going to be negative 12 plus or minus square root, plus or minus square root. Draw a big long square root. B square. Now, what is 12 square? 12 square, it's on the board. You should know it. It's 144. So it's so much easier to go ahead and put B square in there. B squared minus 4AC. B squared minus 4AC. This time the A number is a 4 and the C number is a 9. All over 2A. This time it's 2 times the 4. All right. Calculators. This is a lot of calculations. What are we calculating first? The part that's under the square root is what we're going to put in our calculators first. So here we go. Clearing out the old. 144 minus 4 times 4 times 9. I can use the times button or I could use parentheses, same thing. This answer is what? 0. So this is going to be x equals negative 12 plus or minus the square root of 0 over 8. This is something new. We haven't seen 0 before. This is actually one of those problems that only technically has one solution. The square root of 0 is what? just 0. So this becomes negative 12 plus 0. Divide that answer by 8. It also becomes negative 12 subtract 0 divided by 8. Does everybody kind of see that I'm going to get negative 12 over 8 for both answers? So really, there's only how many? This one only has one solution. All right, this particular problem has no radical form. There's no reason to list that as square root of 0. No reason at all. You would never see that. There is good reason to simplify 12/8, and that reminds me, you can do that on your calculator. Negative 12 divided by 8. If you haven't done this for a while, if you need it, I like to leave it as fractions. So math key, number 1 is fraction. Press enter, and then press enter, and it reduced it for us to negative 3/2. Negative 3 over 2, and there's only what? One solution. All right, let's see, I guess I could put, let me back up just a little bit. I guess I could put negative 3/2, although that's not the radical form. Negative 3/2, I think, is negative 1.5. So actually, this parabola comes down 1, 2. It comes to, oops, almost went the wrong way. 1, 2. It comes to negative 1.5. It comes down, touches, bounces back off, and only touches the x-axis one time. This is what it would look like if you tried to use the quadratic formula. You would end up getting a 0, and that means you're adding 0 and subtracting 0, so you only actually get one solution. Okay, last example, quadratic formula. Is everything in the right order? Sure. All right, A would be a 2. B would end up being negative 1, and C would end up being 8. Okay, let's plug and chug. X equals opposite of B, opposite of B. So it's going to be plus 1, plus or minus square root, plus or minus square root, draw a big long square root. B squared. All right, here's B squared. What's negative 1 times negative 1 twice? What's positive 1? So B squared minus 4 times A, which is 2, times C, which is 8, all over 2A, and this time A is a 2. All right. Might be able to see something here. 1 minus 4 times 2 times 8. 1 minus 4 times 2 times 8. 1 minus 4 times 2 times 8. Ooh, I get a negative 63. So x equals 1 plus or minus the square root of negative 63 over 4. Ding, 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 ding. Is warning bells going off in your brain? I hope they are. You cannot take the square root of a negative. If I tried to even put that in parentheses, 1 plus the square root of negative 63, closing parentheses, and actually I have to close 2 since I've got both, it's going to tell me that top part gives me a non-real answer. So that means that this one has no real solution. That pretty much means this parabola does not touch the x-axis. So there's no radical form and there's no decimal form. This one has no real solution. So if you get the square root of 0, that means one solution. All right? If you get a square root of a negative number, okay, square root of a negative number, that means what? No solution. All right, so you have seen the scenarios of what it looks like with the quadratic formula. If you have, going back to example 1, if you have an equation that does have 2 solutions, that does factor, that gives you nice perfect answers like 5 and negative 7, Then you see when it's really the most helpful is when I have solutions that are decimals that I could never probably ever get on my own, because that would be crazy. But I do have a reason to use the quadratic formula in 2, and I saw value in it with 3. Again, crazy decimal answers. Example 4 is what I saw, or what I had when I only had one solution, and that's when I ended up with the square root of 0. As soon as I saw square root of 0, I knew I was basically adding nothing to the top and subtracting nothing from the top. So that actually gave me one solution. And then the final example, you see what it means if you get a negative number under the square root. That's a big no way, Jose. You cannot take the square root of a negative. So it gives you no answer. That means that particular problem does not cross the x-axis. This is the quadratic formula introduction. Hope it helps.